Hello, my name is Niels Hornig. I'm an application engineer for the MathWorks in the area of electrification and electrical simulation. In the next few minutes, I want to explain you when you can use Phasor mode simulations with Simscape to achieve fast electrical simulations. For this purpose, I will use the displayed live script, which you can also find in the GitHub content linked to this video. So first of all, let's talk about different kinds of solvers for electrical simulation. First off, we have the classic EMT or electromagnetic transient simulation. This picture indicates an approximation of a sinusoidal signal with different samples per period. So what you can directly, 10 samples per period is far too few to accurately represent a sinusoidal signal. Then you also see 50 and 100 samples, where 100 is usually a good rule of thumb as a trade-off between computational speed and sinusoidal representation. Different kind of simulation is what we call an RMS, root mean square, or phasor simulation. Here is not the full waveform simulated, but only a phasor representation of an AC signal like voltage, meaning you keeping track of the phase angle and the amplitude. Now for this kind of simulation, as you can see here, it's usually favored to use a variable step solver, which is able to reduce the step size in moments of high dynamic. As you can see in the second plot, the step size in orange is reduced dramatically in this switching event. And then once things are more stable and we are in an almost steady state, the step size can be increased to achieve fast simulations. So what are the type of simulations you want to use, or where you could consider using phasor mode simulation? First of all, you need the presence of a periodic AC signal with a fundamental frequency. Usually for electrical systems, these are the typical frequencies as 50 or 60 Hertz. Might be different on onboard microgrids, but this is important that you have this common frequency. And then second, the type of question you're trying to answer with the simulation study has to fall into the category of more slow-moving AC signals and AC quantities like the amplitude, or DC quantities like, for example, used for controls tuning for a governor of a turbine, but certainly not something like harmonics or the reaction to faults within one waveform, because this is not suitable for RMS or phasor mode simulation. Talking about limitations, I also want to bring to your attention that there are certain ways to create more or less periodic signals in an electrical simulation. For example, having a voltage source inverter in grid forming mode, whereby the controls sinusoidal voltage is injected or generated at a grid node, or also a controlled voltage source where the AC character, the sinusoidal signal, is only governed by the controls input. These components will not run in phasor mode because they're not classified as a steady frequency phasor component. Moreover, there are some components which cannot be transferred in a switched linear equation, which also will prevent the internal Simscape solver to use phasor representation of frequency and time, as we call it. This will be indicated by the error message, and then in this case you have to stick to the classic time or EMT simulation. These commands will take you to the parts of our documentation for this components or examples, unfortunately not working as phasor mode. Now I want to show you how you can set up such a phasor mode simulation. So first, let's open the model and make sure we will log all of the Simscape data. As you see, it's a fairly simple system where we have a synchronous machine as generator. We have a system for the excitation control, and we have controls for the governor. So you could see this is the active power part and this is the reactive power controls part. Then on the load side, we have a constant load and two switched loads where we will switch them on and off at different points of time to test the system for step load reaction. All commands can be also done in Simulink, but I will use our Simulink and Simscape API in the following to make it more replicable. First of all, before we speak about any ways to make a simulation faster by reducing the accuracy where not relevant, we need to make sure we have a high fidelity representation of the simulation saved. So as base case, let's use, as said, the rule of thumb of 100 samples per period. So we can set our local solver to this resolution. By default, it's switched to is set to time simulation. This command will ensure also via API that it's set to the time. And then we simulate it and record the results. Once the simulation is done, we will now still use the EMT or time-based simulation, but reduce the step size to 100. This is of course unrealistically low, meaning we have one sample per period. It's just useful to be aware of the computational difference to this high fidelity simulation and then this with reduced step size. So now when we switch over to a Phasor mode simulation, we will use the same sampling time, so just one sample per period. However, as you can see with this line, we switch the simulation mode from time to time and frequency. The equivalent action in the graphic editor would be to click on the solver configuration block and locate here in the first line the equation formulation to set it to frequency and time. Once we collected the output and the timing for this run, we can compare now. First, the execution time of the three simulations, where you can see clearly our base scenario with the high resolution EMT takes by far the most time compared to the only one sample per period EMT or the Phasor simulation. You also notice that using for the same sampling time, the Phasor mode has a computational extra cost compared to EMT. But now if we compare the signals, starting with the DC signals, one voltage magnitude and also the velocity of the rotor in our turbine, you see that the Phasor mode results are much better representation to the high fidelity EMT simulation than compared to the 1 second sampled, which is, as I said, does not really make sense for an EMT study to use this low sampling. I just wanted to highlight how this Phasor is now a trade-off, taking more time than a pure EMT simulation for the same sampling time, but almost having the same results as a much faster sampled EMT simulation. And what's a specialty for the Simscape Phasor mode? Not only DC signals but also AC signals can be viewed, because after the simulation is finished, Simscape solver will use the data in form of Phasor angles and magnitudes to reconstruct AC signals around the fundamental frequency. So also AC waveforms of the voltage or the current can be observed. With this, I hope you have a better understanding how you can use Phasor mode or frequency and time with Simscape to achieve fast electrical simulations. Thank you.